Hello everyone, our lesson for today is Introduction to Limits. So, what is limit? A limit is how a function behaves near a point instead of at that point, and it can be notated as the limit of f of x as x approaches a is L. A is an x value and L is the result of a substituted in the function of f. To understand more about limit, first let's take a look at the example. Find the limit of f as x approaches 4 for f of x equals to 2x plus 1. The limit of f as x approaches 4 is the value of f of x as we get closer and closer to 4. For example, if we start from the left and move close to x equals 4, the y value will be close to 9. And if we start from the right and move close to x equals 4, the y value will be really close to 9, as we can see in the chart. As it gets closer and closer to 4, the y value is getting closer and closer to 9. Therefore, the limit of f as x approaches 4 is 9, and this is how we notated the limit of f as x approaches 4 is 9. At this point, you may be wondering what is the difference between the limit of f as x approaches 4 and the value of f at 4. So let's take a look at an example. We have the piecewise function g of x equals to 2x plus 1 if x is not at 4, and g of x equals to 2 if x is 4. As you can see in the graph, as x approaches 4, the limit of g of x is 9, but the value for g as x equals 4 is actually 2. So there is a difference between the limit of g of x and g at x equals 4. In limits, we want to get infinitely close. So let's take a look at the example f of x equals to 2x plus 1 as x approaches 4 again. When saying get infinitely close, what we mean by the limit of f of x as x approaches 4 is equals to 9 is that no matter how close we want to get to 4, there is always an x value that is very close to 4 that will get us there. Let's take a look at this. In this chart, we see that 3.9 is very close to 4, and it will result in 8.8, which is close to 9. But by adding 9 to the right, we can get 3.99, which is closer to 4, and results in 8.98, which is even closer to 9. And by adding 9 to the right, we can get closer and closer to 4 and result in closer and closer to 9. And this can go on infinitely. The same thing goes on with this side. 4.1 is close to 4 and 9.2 is close to 9, but 4.001 or 4.0001 is even closer to 4 and will result in even closer to 9. And this is similar to this side, and it can also go on infinitely. Another thing about limit is that it must be the same from both sides. So let's look at the example. Find the limit of d of x as x approaches 2, and d of x equals to 3 times sine of 1/2 pi times x plus 4. Let's take a look at the graph of d of x. X at 2 is right here. We see that as we're approaching x equals 2 from the left, the limit of d of x is at 4. And as we approach x equals 2 from the right, the limit of d of x is also 4. And since we know that the limit from both sides are the same, we can conclude that the limit of d of x as x approaches 2 is 4. So in this example, we will find the limit of d of x as x approaches 2, but this time d of x is a piecewise function where d of x equals to 3 times sine of 1/2 pi x plus 4 if x is less than or equals to 2, and d of x equals to 3 times sine of 1/2 pi times x plus 1 if x is greater than 2. In the graph of d of x, we see that the limit of d of x as x approaches 2 from the left is at 4, and we see that the limit of d of x as x approaches 2 from the right is at 1. So when we approach x equals 2 from the left, the function approaches 4, and when we approach x equals 2 from the right, the function approaches 1. And when a limit doesn't approach the same value from both sides, we see that the limit doesn't exist. So the limit of the function of d as x approaches 2 doesn't exist for this case. And that's it for the lesson. Thank you for listening.